welcome to Fusion Cam webinar. So we're going to start off with Fusion Cam. So this is with the assumption that everyone can use Fusion a little bit, the design side of things, but this is based on the Cam. So we have another webinar on Monday morning, which will be going through all the basics of Fusion 360, and that'll touch on Cam also, but it'll be more heavily involved in just setting up how to do sketching and extruding, modeling and that side of things. So today we're just focusing on the Cam. So what I want to do is open up a part first of all. So we're just going to pick this part. So as you can see, we have a part here that was designed, and as you all know from designing, everyone decides to design on a different plane, so parts can be uploaded into your own Cam software differently. So at the moment this is kind of uploaded in an angle that we wouldn't machine it. So first thing we want to do when we're looking at machining parts is decide on how we want to go about machining. So if we're looking from the top down, the head of machine would be coming down here, so this wouldn't be ideal. So what we want to do is flip this part. So at the moment we're in our design environment within Fusion 360. So if I click over here, we go into manufacture. This is where all the Cam happens. So turn that into the manufacture. So as you can see, our part is on its side, so we want to have it face down, so this is going to be facing up. So what we want to do is move it into the correct orientation for what we want to look at it. So this is how we want this to be machined. So now that we have this sitting in the correct orientation, I'm going to right click on the house, set current view as home and fit to view, and then also I'll touch on the top. So you can see here it says front, but it's actually the top. Again, I'm going to right click, set current view as top. So straight away we have our setup realigned. So we have our top with our top, and if we click the home, it'll give us isometric view. If we go back to design over here, it keeps it to what it originally was. So you can see the two different views are different. We go back to manufacture, click on the home, and it brings us into our view that we want. So the next thing we want to do is create a setup. So we have a setup created here already, so I'm just going to delete this. So this is what we'll be given when we move into manufacturing environment. So up here we can change this from mil to inches. So I'm going to leave it on mil, and we can start working. So what we want to do is create a setup, which involves getting a datum and giving it a stock material to work with. So up here in the top ribbon bar is where all the functions we're going to be using are. First of all, we're going to do setup. So this is the setup button. It's the very first button under the milling section. Again, we have different sections here that we can flick through, but we'll be focusing on milling today. So we're going to click on setup. This gives us a dialog box, and it has 3 different tabs. I only ever focus on the first 2 tabs. So the first tab is setup. Here it's looking for machine. So again, I never use this function. Setup. So here is where you would give it what type of machining we're going to be doing. This is going to be milling. Next thing we want to do is the orientation. So the orientation sets which way the X, the Y and the Z corresponds. So as you can see at the moment, the Z is coming out the side of the machine, Y, so it's all muddled up. So what we want to do is I always select the second option here, which is select Z plane and X axis. What this does is it asks us which face is the Z. So the face is, we can touch off any of the faces, so we'll touch off this. So now you can see the Z is already aligned perfectly. The X, it looks for something to correspond off, and again we can hit a line that is on the X. So because this X is already correct and the Y is correct, we don't need to touch it in there, so we can skip that But for instance, if it was this way, our X is pointing the wrong direction, we'd go into edge and we would click line. That gives us our X. We can flip the Z axis if this was pointing the opposite way. So you can see it moves. And then again we can flip the X, which will flip the X and the Y. Or alternatively, we can select the actual arrow and it'll jump for us. So this is the correct orientation of what we want for the moment. The next thing we want to do is find a point on the part to call our X, Y and Z. So again, we have different options here. We can go model origin, which it'll look for where the part was designed off X and Y. We can go selected point, which means I can pick any point on this part to call my XY. So if I wanted my XY to be here, we can go model box point or stock box point. So stock obviously goes off the material. So this clear glass you see is the stock material at the moment, but we'll be changing that. So model box point is what I'd always use, and we can go with this point here. Model is body, so it's already found the only body that's in this environment. If this environment had a few different fixtures or vices or clamps around it, it may ask you to select what the actual body you're machining. So you can see it's looking for, it doesn't pick up anything there when I exit. So we're going to click on this, there's our body. And fixture, this is if you do have fixtures and tools and clamps around a machine or a fork axis, you'd turn on the fixture and you'd click on all the different bodies that are around the component. And this is mainly for clash detection. So when you're running your toolpath, it'll pick up if a tool hits off the vise or the fork axis or clamps. So because we don't have any other items in the environment, we can turn fixture off. Next thing we want to do is go into stock. So sorry, I'm just checking to make sure that none of you are writing any messages or asking any questions. Stock, so what we're going to do is, again, there's different options here. So we can go fixed sized box, a relative sized box. You've got cylinder if you're machining out of bar stock. Fixed size allows us to tell it the width, the depth and the height. Relative size is what I'd always use. So if I want to add on 5mm to all sides around it, I can add on 2mm to the top of the part, and I can add on 10mm, so I'll be able to grip the part in a vise. And again, we've just got round up to the nearest, which just helps if for the buyer of your company. So if you wanted to round up to 10, it'll just bring in these figures to the nearest 10, etc. So I'm going to leave that at 0. I'm going to OK that. Now that we have our X and Y and Z, we can see there our Z is on the top of the part and our XY is bang on the corner point. So OK that. Now we're ready to start running toolpaths. We have our datum and we have our stock material. So the next thing we want to look at is all our toolpaths are here in 2D and 3D. So there's different ways, everyone has different ways of machining, so we can just look at a few different options here. So the first thing I would do here is run a face mill over this part. And to just show you how easy it is to be doing toolpaths, what I always do is I'd select a toolpath, I select a tool, I pick a geometry and I press OK. See what the tool does, and then I work backwards. If I wanted to speed up the machining time, or if I wanted to cut in different directions, I'd go back in and manipulate, and I'll show you how to do that. So we're going to go 2D, look for the face mill option. So here we have a dialog box. So the first thing we want to do is select a tool. So every tool path has these same 5 tabs. The first tab being tool, the second geometry, heights, passes and linking. The passes is all about when the tool is engaged in the material, and the linking is all about when the tool is entering or exiting the material. So what we're going to do is select a tool, I'm going to choose a 50mm face mill, OK that. And here you have all your feeds and speeds. The second tab is geometry. So at the moment all I've done is selected a tool. We can see our tool here, 50mm face mill. I'm going to go into geometry. It already highlights the boundary of the stock material, so I'm OK with that. So I don't want to do anything at all. As I said previously, I've selected a tool and a geometry and I press OK. See what the tool does, and then I can go back in and manipulate. So you can see the toolpath here is running. So the green is when it's off the material and the blue is when it's engaged in the material. So if we weren't happy with this cut, that we wanted to do it differently, you'd go in and you'd manipulate this tool. So you can see it's taken 53 seconds to do that. If you wanted to go in and change around with that, we can double click here and it'll bring us up the same dialog box to go in and start playing around with feeds and speeds and cut direction from your heights to your passes to your linking. So again, I'm not going to do anything, so I'm just going to leave it for now. The other thing you can do is also right click and you can go into edit, which brings you into the same dialog box. So that's our face mill. If we want, we can run a simulation on that. So if I go up here, I can press simulate, or I can just right click and simulate on the tool, or I can go into setup and right click and simulate. It's always best practice to select setup, because when you've loads of toolpaths, if you select the tool and simulate, it'll only simulate that one tool. If you click setup, it'll do the whole lot. So if we go simulate, here's our simulate dialog box. Again, I can switch on and off the tool for visual effects. I can turn off and on the toolpath, which will leave a trail line behind it, and I can turn off and on the stock. I usually just leave the tool on, the toolpath as tail, and colorization as comparison. So the comparison will show you what's machined and what's not. Down here we have our button control. So again, we've got play, we've got fast forward, we've to go to next operation and go to the end of the operations. So if I click on play, we can see the face mill and what it's going to do. And there we have green, which means that is now a tough size, while purple means there's still material to come off. So I'm going to go and close our simulation. And again, to do that simulation, you have your button here, or you can right click and simulate. So the next thing we want to do is rough out this part. So if I go 2D, adaptive clearing, again we get presented with the exact same dialog box with the 5 tabs. So I'm going to go with tool. It always picks up the last tool you've used in an operation, so it already has 50mm face mill in there, but we don't want that, so we want to go select, and I'm going to go into a 12mm end mill and select OK. Geometry, there's no geometry selected, so I'm going to select this geometry and I'm going to press OK. Again, I select the tool, I select the geometry, and I look to see what it does. So as we can see, it's ran around the outside of the part here. If I go back in and select geometry, if there's no geometry selected, it looks to see what you want to machine. So the other option, what we can do here is, if I delete out that, so I can right click and delete, I'm going to go 3D adaptive clearing, and you just see the difference between the 2D and the 3D. The 2D, it follows the toolpath that we've given it, or the boundary. So again, I'm going to go select the tool, end mill, 12mm, okay, that into boundary. So it picks up the outer, again the outside of the stock material this time for the 3D adaptive, and I'm just going to select OK. And there you can see it looks for all the different, to take out as much material as possible within the boundary that we've given it. So again, if I go, and you can see it runs over the top of the part, so that means if I go back in here to edit, into geometry, it looks for the rest machining from previous operations, which means it looks for this operation to see what it's already taken off, and it'll remove that. So now it should miss the top of the part. So you can see now it just takes the pocket off and it leaves the top surface. So that's rest machining. So again, if I click on setup, simulate, I can press go, I can skip that tool and go straight into the roughing tool. And we can just speed it up by pulling this slider out. And there we have our part ready to go for the next operation. So again, green is finished, everything else is it's left on material. So what I can do is go back in here, edit, and now if I go into my passes, I can see down here radial stock to leave, which is 0.5, which means it's leaving 0.5 on all the walls. I'll bring that down to 0.25. And axle stock, which means it's leaving on the base, on the floor of the part. I'll go to 0 on that, and I can OK that. And that was within the passes tab, because it's engaged in the material is what I wanted to change. So if I go back in, simulate, and I skip the first tool and skip the second tool, now you can see that there's a lot more green. It's after taking off all the material from the floor of the part, but it's still left on 0.25 on the walls. So the next thing I want to do is do a finishing pass. So if I go 2D contour, select tool, so it's looking for, it's already chosen the 12mm, so I'm going to leave it because I'm going to use the 12mm. I'm going to select contour, so I'm going to select this line, I'm going to select this, and I'll need to use a smaller cutter to go in there. So these are the two faces that I want to finish up, and again I can select these arrows, and now it'll do the inside, so it'll cut from the inside out, which would be wrong. So just showing you that if the arrows are on the inside, you just click it and it jumps to the outside. So I'm going to OK that, and you can see the cutter has ran around there. So the last thing we want to do is run a smaller tool, so I can go 2D contour again, I'm going to select end mill, I'm going to go to 6mm, OK that, select the boundary, which is going to be in here. And again, be careful when you're selecting boundaries, because if I select this boundary, the cutter will obviously only go as deep as this line. So we want to select the bottom of the pocket, and again the bottom of the pocket here, and we can OK that. We can also do an extension here, so if I go formal extension, OK that, you can see the extension, it comes out beyond here. So this is what the extension is about. So you get a clean cut on these walls. Again, I can right click and simulate, bypass the first tool, bypass the second tool, go in and run the third tool, and there we have that part almost complete. So you could see there a second ago when it was running the toolpath, you could see that the cutter turned red, so that means there was a crash, and you can see it on the back of the wall here. You can see that there's grayed out, which means there's an issue that happened there. Our timeline when we're in simulation, it gives us nice details here, and you can see right there there's a collision on the red. You can see there's a little red tick here, so if I hover over that, it'll say holder collides with stock, and again we've another tick here. I can click on it and show where it's colliding, and it gives some information about the collide as well. So again, handy things to have there. So how to fix that collide is we'd have to pull our tool out of the holder a little bit more. So we can go into here and we can edit, we can edit the tool. So I right clicked on adaptive, and here is where we can edit. So I can change that 27 to 50 mil, etc. And you can do that in any of the tools, or you can go into your tool library up here and change it within there also. So the last thing we want to do is start drilling out these holes. So the quickest thing to do for drilling out holes is you can do hole recognition, or you can do a hole where you choose the hole yourself. The hole recognition is a good feature. So it looks for every hole that's on the part. So you can see the 15 mil, and it's going to ignore them. So I can choose what to do here. So drill in countersink and drill in countersink here. So I have 8.5 holes and I've got 8.2 holes. So if I just go ahead with what it's already telling me to do, you can see down here it's generating a hole recognition path, and this just takes a couple of seconds. You can see down here in the corner it's just generating. And there we have 4 toolpaths. So we have a spot drill, our 8.2 drill, and our 8.5 drill. If we go to the front, we can see how deep they're all going. And again, you can right click and edit in each of these tools if you want to change feeds and speeds, or the cutter or heights, etc. Inside here is where you have all your different from reaming to tapping to boring. There's plenty of different options in there. So again, we're happy enough with that. The last thing we want to do is drill out these 4 holes. So I'm going to use the other function this time, which is drill. I'm going to select, I should have checked how, so I want to inspect the size of that. So it's a 9.05 hole, so we'll drill it out with a 9 mil. And again, you've a measuring tool up here which helps you measure lots of different features. So if you wanted to check the height of that, 20 mil, etc. So we're going to go drill, select, find the drill. We're going to go, I'm going to drill at 9.1. I'm going to select, and here you have different options to select. So I can go diameter range, so I can go from 8.8 to 9.2 to make sure that I've selected all 4 holes. Again, we could easily go from 2 to 9.2, and it'll pick up every hole. So we're going to go 8.8, and that'll just pick up these 4 holes. And again, we can do full retract, deep drilling. We can change our peck and size, and we can OK that. The last thing we want to do is we can bore out these holes, and there's different ways to do that. We can use a boring cycle, or we can just do a 2D pocket cycle. You can do circular cycle. So we will go with bore. I'm going to choose end mill, go with a 10 mil end mill. Geometry we want to use. So I want to take that out, take that out, take that out, take that. Okay, that. Okay, so now we're ready to go. We have our part fully completed with all our toolpaths. So I'm going to go simulate. And there we have our part fully completed. Obviously I left in the clash there, I didn't fix that. But that's how you run your toolpaths. So if I close that, so at this point we've set up all our toolpaths, we've simulated, we're happy with everything. The next thing we want to do is post our code out to the machines. So what we're going to do is up here beside simulate, you've got post process. So if I click into this, we have an option of all the different types of machines, and there's more that you can download and upload into Fusion 360. So I'm going to look for a Haas machine. Here you can tell it which type of operation to minimize the amount of different options you do get. And I'm just going to go with this. Here you've got a load of different values, and it's all for just cleaning up your post, so you can read it a little easier, and it just tidies it up. Post this, save it in there, okay to that, and here you get all your code that you can transfer into your machine then for this operation. Again, up here beside post process, you've got setup sheet. If I click setup sheet, select the folder, and here you have a setup sheet that you can hand out to the operators on the floor, so they can see what they're machining, where the datum is, what the size of the stock is, what the size of the actual part is, each tool, the speed of the tool, certain different details about the tool, what size it is, how long it's sticking out, etc. So that is also very handy to have. And that's kind of how to run our toolpaths. So the last thing I want to show you before we finish up, just checking messages there again. So the last thing I want to show you before we finish up is, so if I go back into design and I unisolate the part, we can see we have a vice here. Go back into manufacture. So within Fusion 360, it has a massive tool library of vices and chucks and clamps and 5-axis and tables that you can use and upload into your design. So this is where I was saying that the setup would come in handy. So if I wanted to go back and right click in setup and I want to edit it, I can come into fixture and I want to choose this as our fixture, this, etc., and you can choose plenty of different things. So when I select OK on that, it gives us up a load of red arrows. So what I want to do is regenerate, because it's noticed that something in the environment has changed. So there's the generate button, so right click and generate, and if I go to simulate now, we'll probably see a lot more crashes happening. So you can see all the crashes there now because it's trying to machine down into here, but it's hitting off the vice straight away. So that's the nice thing about bringing in your voice and clamps, etc.
Ronnie, would it be possible to show a second setup on the vice you're lowering?
Oh yeah. Give me a sec there, Mark, and I'll come back to this lad. Hi, Gerard, is it?
Yeah.
Sorry, what were you looking for?
Say, Brian, if you, the big problem we have was on the edge cam is on the second operation, say if there's machining bit done on the opposite side of what you machined already.
Okay.
We have some problems with that. Have you features on the opposite side that big you could machine?
I just have to skim off the back face. But what type of problems would you be facing?
What comes in is that you machine the part on, say, what you've done there.
Yeah.
You've taken, you've machined it out. When you turn it upside down, what you have is it kind of ports in like an STL file, and the graphics on it are to be bad. I'm just wondering how Fusion would handle the second setup.
Okay. So like I'd probably run the second setup the same as I've done the first. So like I'd go into the second setup up here. And again I would we could turn it up this way and just do that again. So we have our first setup here.
Okay.
So I'd go back in and click on setup here again, and we can go with turning this upside down, setting my Z this way instead. So now we've our X, Y, and Z set up in this orientation.
Okay.
So we will go with box point again in the model. So if I choose this point, and the stock doesn't really matter at this point.
Well, it does because you had 10 mil left on it there. It doesn't bring in the stock from the last time.
No, like what you'd do is you'd just add on. So like when you're finished your op 1, you'd measure. So yeah, if you're saying there's 10 mil on the top.
Yeah.
So what we'd do is we'd add on the 10 mil here. So now you can see we've 10 mil added on here.
Okay.
And I just okay that for now. So now you can see like this is kind of I'll go back in here to setup. Just go back into stock. Like you can change this to fixed size, so you can actually be very more accurate with what you're what your stock is left on the part for the second side. So you could leave 0 stock on the so the bottom there we've no stock. Top we're button on 10 mil. On the side we can put back on 5 mil because that's kind of what we had in the first one. Okay that.
Does it automatically know, say you use the size of that machine already, does it automatically know what it has machined? As to me there'd be a step in that billet now showing where you have machined.
Yeah, I get you. Like the step, like so what you'd be doing is kind of creating the materials. So like your step would come out here. And then it would come up to the back here.
Yeah.
So
that's what you would actually be looking at.
Yeah, so like you can go in and
would be a stop update button. That's very.
There is a way of doing this. I just need to look into it a little bit more, but you can replicate exactly what's left on.
Yeah.
I can look into that and I can get back to you with that. I can.
That's pretty. But a lot of our parts they can be very big, and we might have to do multiple setups on it. Like moving the part on the bed couple of setups to get just machine one side of it.
I get you.
It would be critical for us that we would be able to do that. Right.
Yeah, let me come back to you on that. Like, and I'll just reach out to one or two of the other guys that I'm working alongside with this.
Yeah. No, everything looks great on it. On it. Brilliant demonstration.
Like
just curious how Fusion handles or Inventor can.
yeah, like I think you can create a stock setup, but I want to look into that a bit more before I come back to you on that.
I appreciate that. Thank you.
Is that all, does that answer like? And you're happy enough like when you're on this setup, then you just start creating more toolpaths within that.
If that setup had shown that there
What?
was what stock was actually left.
Yeah, I get you. I'll come back to you with that one, Jared. Mark has your email there anyway, so.
Yeah, thanks very much for that, Brian.
No worries. Hope was it beneficial to you anyway.
Yeah, no, it was, definitely was.
Good.
Thank you.
Excellent. All right, take care.
Alright, have a nice day.
You too.
Thanks.
Bye now. Bye. I hope that's helped you all. If you have any questions, feel free to drop me an email. My email is b.fagan@procad.ie, or you can email Mark Foley as well, which I believe you all have his email address there anyway. Okay, thank you very much, and we'll see you again.